Okay, so we're going to finish the second part. The second part, we are finding zeros, roots, solutions. These all mean the same thing. And we're talking about our polynomials. We can also include the word x-intercept. This is where we're crossing the x-axis. So right now we know if someone gave you x to the fifth and it was positive, you knew it started down, it finished up, it had some humps along the way, but we don't know exactly where it touches the x-axis. And this is going to help us out with our graphs to make them look a little bit more exact. Right now we have general sketches and just knowing in behavior. Now we're going to add a couple more things to it. So if you're trying to find your zeros or roots or solutions or x-intercepts, all the same thing, you're going to move everything to one side, factor it, set the factors equal to 0, and solve. Does this sound like a familiar process? Yes, it's exactly what we did for quadratics. We're going to also do this for polynomials as well. Most of the problems you're given today will have already been factored for you, so we just have to worry about setting our factors equal to 0 and solving them. Okay? There's only, I think, 8 of them that you have to factor. They're all pretty straightforward factoring ones in your homework. So we're going to start with our first example. It has x plus 1 times x minus 3 times x plus 4. We want to find our zeros. We're going to also, once we do that, we're going to draw a rough sketch. I'll show you how we can use this to draw a sketch. So first off, let's see. If you multiplied this all the way together, what degree polynomial do you think this would be if we multiplied all 3 of these together? It would be third degree polynomial because x times x times x makes x to the third. So when it's already factored like this, you need to go through and think, what degree is it going to be? Because that's how many roots I'm going to find. And it's also going to let me know the shape of the graph. So I look at it, x times x times x. This is going to be x cubed. And when I graph it, there's not a negative in the front. So it's a positive x cubed. I know I'm going to have to graph it. It's going to be down up when I sketch it. So that's just what I do before I find my zeros. X times x times x is x cubed. It's positive x cubed. That would be down up. Now we're going to write down what our x values are, what our zeros are. So this is just like a quadratic, but they've added one more factor. Everything else is the same as we did in the last chapter. So if you have x plus 1, what is our solution? If you have x plus 1, what would our 0 be? What would make it 0? Negative 1. Good. If you have x minus 3, what would our solution be? What kind of 3? Positive. If I have x plus 4, what is that third solution going to be? And that will be negative 4. We get those by setting them equal to 0 and solving. We've already done that a whole bunch, so we know right now at this point that we just change the signs if x is to the first power. Okay? All right, now we're just going to do a very, very rough sketch. These are the 3 places where our graph crosses the x-axis. So we cross at negative 4, negative 1, and 3. Our arrows tell us that we start down, finish up, and to connect, you just slowly go through, make your curves in between your graphs. Connect, go through, connect. So we tied together the end behavior with the zeros, put them on the graph, down, up, made our connection. Okay? Everybody good with finding the 3 zeros? Thumbs up for that? We just change the sign. Everybody okay knowing it's x cubed? X times x times x makes x to the third. Then we check our end behavior from above. All right. The next we're going to do is a little bit different. We'll write our end behavior down first and then identify what our zeros are. What degree are you guys thinking on number 2? Let's see, we've got an x, and then x squared. X times x squared is going to be x to the 4th, right? X times x is x squared. Times x squared is going to be x to the 4th. Okay. So x to the 4th. You only have to do this multiplying stuff if you have it in factored form. Is this a positive or a negative graph? It's positive. So positive x to the 4th, our arrows are both going to be going upward. Now we're going to write our zeros down, or our solutions, or our roots, or our x-intercepts, whichever way you want to call it. Our first one, remember when we would pull an x to the very front of something, you would set x equal to 0 at the beginning. If x equals 0, what does x equal? 0. It wasn't a trick question. If I said x equals 0, then x must equal 0. So that's our first one. What's our second one going to be? We have x plus 2, negative 2. Our third one we can't just look at. Some people would guess negative 6, but we have this squared. If you have a squared, you can't just write it down. You have to actually write it out and solve it. Isn't that the pits? So I set it equal to 0, subtract 6 on both sides. How are we going to get rid of this x squared? What do we need to take on both sides? The square root, right? All of these things are coming back to haunt us from last lesson or last section. Can we have a negative in a square root? What hops to the front if there's a negative? What letter? Letter I? Okay. So I have my 4 solutions. My first one was 0. My second one was negative 2. My third one is positive I root 6. And the fourth one is negative I root 6. So 4th degree means we're going to have 4 solutions. How many of these 4 numbers actually touch the x-axis? Just 2 of them. The ones with the eyes don't actually touch the x-axis. So it will cross at 0 and negative 2, doesn't cross at the eye. All right. I'm not going to sketch that one because I don't know exactly how far down it goes or the loops it does because of the eye in there. You won't have to graph any with eyes on your homework. All right, let's go to number 3. What do you think the power is on number 3? What's our degree of this polynomial? How many here? 2, 1. And how many times is x plus 4 represented? It's represented twice because of the squared. So we've got 1, 2, 3, 4, 5. So this degree polynomial is x to the 5th. It's also positive, so our graph is going to be down, up. We write something special if a root or a factor shows up twice, or if the whole thing is squared like this is. We want to let whoever's looking at this know that we know that x plus 4 is on there twice. we know that x is on there twice. So we write that there has multiplicity, like that there's a multiple 0 or multiple root. We always just abbreviate it though. So for our first one, the first one's going to be 0. And we write 0 mult. I spelled mult wrong. It's not 2 U's. Silly. So 0 mult 2 means that 0 was a root twice. You had x and another x. What is our second root here? If you have x minus 3, what is it going to be? Positive 3. Our fourth and fifth root, because we had it twice. You have x plus 4. What kind of 4? Negative 4. And since the entire x plus 4 is squared, it also has multiplicity. It is a root 2 times. So if I were listing these out, I would have 0, 0, 3, negative 4, and negative 4 again, which makes 5. And that's what our degree was. You want to see what this one looks like when you graph it? It's kind of crazy. We cross at negative 4. We cross at 0. We cross at 3. We go down and we go up. But when a graph has multiplicity, when you're going to that root or that x-intercept, you don't go through the graph. You hit the graph and you turn around and curve. So I'm not going through negative 4 because there's multiplicity. I'm going to turn around. I'm not going to go through 0. I'm going to turn around. I am going to go through 3 though. So if it has multiplicity of 2, it doesn't actually go through it. It just hits it and turns around. I'm not going to have you graph any with multiplicity, like on a test or something. I'll have you graph some that look like this. I just wanted to show you what it looks like. Okay? Y'all's eyes got real big, like. But if we look at it, does this look like x to the 5th? 1, 2, 3, 4, 5 sections to the 5th. All right, the last problem that we're going to do finding the zeros in is one that you will have to factor, and this is the type of problem that you have in your homework to factor today. We'll factor a new kind that you haven't seen yet, but that'll be on Wednesday. We'll spend Wednesday just factoring problems. But if we look at this problem on number 4, I'm going to go ahead and write the degree down before I do my factoring. What's the degree of this polynomial? What's the highest power? 3. This is x to the 3rd. It was positive, so my graph is going to go down, up. I didn't have to do any adding or multiplying or anything on here. It was just written in standard form. That's when you look at the highest power. These other ones weren't, so that's why we were having to count the x's and the powers. All right, what do all 3 of those terms have in it? We're going to factor it. All 3 of these terms have a what? Y'all can show me what's in all 3 of those. Give me a hand signal. They all have an x in them. Okay, good. So we're going to pull our x to the front. Now you just factor what's left in parentheses. What 2 things multiply to 6 and add to 5? Three and 2? Yeah. Okay. So we factored it, and now we're going to write down our solutions. You guys write down your 3 solutions, and we'll check and make sure that you got it right. So just go ahead and write down your 3 solutions. Remember, we changed the sign if it's in the parentheses. If it's an x in the front, that's a 0. So write your 3 answers down, and I'll double check them. Does anybody want to give me your answer? You think you got them? Think you got all three?
Is it 0, -3, -2?
Perfect. 0, -3, and -2. So if you set x equal to 0, you get 0. If you set that equal to 0, you get -3. This one would be -2. Okay. If you wanted to sketch it, it's very similar to the first one that we did. You put a point on -3, a point on -2, point on 0, down, up, and connect. Any questions about finding the zeros from factored form or when you have to factor it? It's very similar to quadratics that we did before. Okay. Just remember, if there's a squared in there, you will have to set it equal to 0 and factor and do the square root for that part. All right, the very last thing is they're going to give you the zeros. You're going to work backwards. So they're like giving you the answers. You're going to put them in parenthesis form, and then we're going to write it in the polynomial form. Okay? So we're going to start out in factored form. Then we'll do some distributing to get our answer. So if someone said the zeros are 1, -2, and 3, you would tell them that you need how many sets of parentheses in this problem? You're going to need 3 sets of parentheses. We need a set of parentheses for each of our zeros. Okay? So think about working backwards. If I wanted 1 for my first solution, what needs to go in my first set of parentheses? X. I want +1 for my first solution. So what needs to go in here? X -1. Because if you had X -1, remember to switch your sign, you would have the +1 for your solution. What's going to go in your second one? X +2. And in our third would be X -3.
Miss Roselle.
Uh-huh.
Can I go ahead and log off?
Yeah, just make sure that you watch this last example. I'll post it. Watch that so you can see it.
Thank you.
Mm-hmm. And do you guys want me to show you how to multiply from here? Do you know? Have you ever done 3 together? Do you want me to walk you through it? Okay. So when you have 3 things and you're trying to multiply them together, you pretend like the last one doesn't exist right now. You just kind of cover that one up, and we'll multiply the first 2 like we always have. And once we get that together, then we'll incorporate the third. So I'll draw my arrows. So x times x is x squared. X times 2 is 2x. -1 times x is -x. -1 times 2 is -2. So we combine our terms in the middle. 2 minus 1 is just 1x. Okay? So once you have distributed your first 2, then we bring down the third. Have y'all ever done a trinomial times a binomial? It's the same process as a binomial times a binomial. With these, we started with x and we had to multiply by everything. Then we moved over to -1 and multiplied by everything. Same thing, except we have 3 to start with. So we do x squared, multiply. Do x, multiply. Do -2, multiply. Okay, so we distribute 3 times, or thrice, as some would say. So x squared times x makes x cubed. X squared times negative 3 is negative 3x squared. And we move over to our middle term. Do multiple colors so it'll help. X times x is x squared. X times negative 3 is negative 3x. If I make a mistake, let me know. Sometimes I mess up on minuses and positives. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Now we just combine our like terms. And you get f of x equals x cubed minus 2x squared minus 5x plus 6.